Hello, welcome to We Learn. In this video, we will cover Chapter 1 Chemical Reactions and Equations. This is Part 2 video. Part 1 is already posted in our channel. If you have done see that, please go and visit that. See, in this video, we will cover about types of chemical reactions. There are 4 types of chemical reactions. Combination reaction, where reactant A combines with reactant B and forms a product AB. Next one is a decomposition reaction. Decomposition reaction is opposite, exact opposite of combination reaction. Here, reactant AB will decompose to product A plus B. Next one is the displacement. Here, 3 and 4 are the same category of reactions. Third one is a displacement reaction. Here, single displacement will take place. Fourth one is a double displacement reaction. A displacement will take place double time. Okay. See here, a reactant AB reacts with another reactant C and forms AC. See, B is displaced by C. Okay. So AC will be formed plus B. Here in double displacement reaction, a reactant AB reacts with another reactant CD. Here displacement will happen twice. Okay, double time the displacement is happening. So AB in AB, B is displaced with C, and in CD, C is displaced with B. Okay, so these are the 4 main types of chemical reaction. Here is a pictorial representation. This is a combination reaction, decomposition reaction, single displacement reaction, and double displacement reaction. Here we are going to see about combination reaction. See, this is an example. Hydrogen combines with oxygen and forms water molecules. Okay, see here, hydrogen is combining with oxygen and forming C, oxygen, hydrogen, hydrogen. Okay, so this is an example of combination reaction. See, there is an activity 1.4. We have to take small amount of calcium oxide and water has to be added to it. Okay, we have to touch the beaker and we have to observe the changes. See here, calcium oxide vigorously it reacts with water and produce calcium hydroxide. Calcium hydroxide is nothing but slaked lime. Okay, plus heat. Heat is liberated out of the reaction. So it is a combination reaction. Calcium oxide combines with water and forms calcium hydroxide. So this is an example of combination reaction. When calcium oxide is added to water, a combination reaction is taking place and calcium hydroxide is formed. Do you know a solution of slaked lime? Okay, see, slaked lime is produced by the reaction of calcium oxide with water, right? This calcium hydroxide, that is slaked lime, is used for whitewashing purpose. This calcium hydroxide slowly reacts with atmospheric carbon dioxide and forms calcium carbonate. Okay, calcium carbonate actually gives a shiny finish to the walls, and even the molecular formula for marble, the chemical formula for the marble is also calcium carbonate. Next, some more examples of combination reaction is burning of coal. Coal is nothing but carbon. Okay, carbon burning is nothing but oxygen. Okay, when oxygen is getting added, see, for all the burning process, oxygen is required. Okay, carbon combines with oxygen and forms carbon dioxide. Next one is the formation of water. We saw this example earlier. Hydrogen combines with oxygen and forms water. In simple words, combination reaction is nothing but when 2 or more substances combine to form a single product. Next one, we saw that heat is liberated when calcium oxide is reacting with water. We got a calcium hydroxide, slaked lime, right? In that process, heat is liberated. When heat is liberated out, okay, heat is released along with the formation of the products. That reaction is called exothermic reaction. Endothermic means heat will be absorbed. See, another examples, as we saw earlier, burning of natural gas. We saw burning of coal, right? Here, burning of natural gas. Natural gas is nothing but methane. Okay, methane combines with oxygen and form carbon dioxide and water. Next one is a respiration is also an exothermic reaction. See, we know that glucose combines with oxygen and releases energy, right? So carbon dioxide, water plus energy is given out. Okay, so this is also an exothermic reaction. Okay, next one is a decomposition of vegetable matter into compost. This is also an example of exothermic reaction. And here, identify the type of reaction taking place in activity 1.1. We saw that, right? So magnesium ribbon is burnt in presence of oxygen. So burning is nothing but oxygen is getting added. Okay, see, when magnesium is burned, magnesium ribbon is burnt, it forms magnesium oxide. So it is a combination reaction. Okay, formation of single product is taking place. Two reactant combines to form a single product. It's a combination reaction. So next we are going to see about decomposition reaction opposite to combination reaction. So here water molecules break down into oxygen and hydrogen. Next one is the activity. Take about 2 grams of ferrous sulfate crystals in a dry boiling tube. Note the color of ferrous sulfate crystals. Eat the boiling tube, and we have to observe the changes. Okay. See here, we have noticed that green color of ferrous sulfate crystals is changed. Have you noticed? See here, when we take ferrous sulfate and when we heat that, ferric oxide is formed. Okay, so ferric oxide is formed plus sulfur dioxide and sulfur trioxide are formed. Okay, so ferrous sulfate is a solid. Okay, ferric oxide is a solid, whereas sulfur dioxide and sulfur trioxide are the gas. Okay, so decomposition of calcium carbonate. Uh, here the question is asked, right? Have you noticed green color of the ferrous sulfate crystals has changed? Yes, it is changed because ferrous sulfate is decomposed to ferric oxide. So the ferric oxide is a colorless solid. Okay, so green color diminishes. Next one is the decomposition of calcium carbonate to calcium oxide and carbon dioxide. Okay, here calcium carbonate. Okay, calcium carbonate upon heat is formed calcium oxide and carbon dioxide. Okay, see, when this decomposition takes place by applying heat means we will call it as thermal decomposition. See, when a decomposition reaction is carried out by heating, it is called thermal decomposition. Okay. Next one is the activity 1.6. Here, lead nitrate we have to take. In the similar way, we have to heat it. We can observe that the brown fumes are coming out. Here, the decomposition reaction is taking place. See, lead nitrate upon heating it will form lead oxide plus nitrogen dioxide. This nitrogen dioxide is a brown color gas. That's what we can see, that brown fumes are coming out. Plus oxygen. Okay, it is also an example of decomposition reaction. Next one is activity 1.7. We have to take a plastic mug and we have to, we have to drill 2 holes, okay, at the base of the plastic mug, and we have to fit rubber stoppers. See here, brown color rubber stoppers are being fixed, and we have to insert 2 carbon electrodes. 2 carbon electrodes are fitted, and connecting these 2 carbon electrodes with a 6-volt battery. Okay, and then we have to fill water such that the electrodes should immerse. Okay, after that we have to add few drops of dilute sulfuric acid to the water. Take 2 test tubes filled with water and invert them. So we have to take 2 test tubes filled with water and we have to invert them. As time goes, we can see that water is displaced by the bubbles. Okay, they are asking us why uh, these bubbles are formed, because electrolysis is taking place when electrode is connected with battery and electrolyte water with sulfuric acid is added. No, so electrolysis is taking place where hydrogen and oxygen gases are collected in the test tube. See here, is the volume of the gas collected is same in both the test tubes? No, it is not same, because water is getting electrolyzed, right? See here, on electrolysis we have 2 hydrogens and 1 oxygen. atoms in a molecule of water, right? So we will get double portions of hydrogen gas and only a single portion of oxygen gas. Next one is after collecting the test tube, we have to burn it with a burning candle. Okay, when we do that, the hydrogen gas containing test tube will burns with a pop sound. Okay, next one is oxygen. The oxygen containing test tube will burn in a brighter manner. Okay, that will be the difference. Next one is activity 1.8. We have to take silver chloride in a china dish. What is its color? And we have to place it in a sunlight. And we have to observe the changes. See, we know that the silver chloride is a white crystalline chemical compound. Okay, when we, when we place this in front of sunlight, means it will decompose into silver plus chloride. We know silver is a gray metal, right? So the color changes from white to gray. Next one is a silver bromide. See, similar to silver chloride, silver bromide also behaves in the same way. So the silver bromide upon sunlight, in presence of sunlight, forms silver plus bromine. Okay. Next one, see what form of energy causes this decomposition. See, some energy has to be applied for the decomposition reaction, right? The energy can be in the form of heat, light, or electricity. Okay, for the breaking down of the reactions in which energy are absorbed is known as, see, as we saw earlier, when energy is heat is released or energy is released, we call it as exothermic. When it is absorbed, we call it as endothermic reaction. Next one is to carry out the following activity. We have to take 2 grams of barium hydroxide in a test tube, and we have to add ammonium chloride into that. Okay, see, when ammonium chloride is added to barium hydroxide, it leads to the formation of barium chloride plus ammonium hydroxide. This is the chemical reaction. Okay, chemical formula, barium hydroxide upon addition of ammonium chloride forms barium chloride plus ammonium hydroxide. Okay, see, when we mix that, we can see that the test tube is becomes cold. Okay, the test tube becomes cold due to the absorption of heat. When heat is absorbed, we call it as endothermic reaction. So it is an endothermic reaction. Next one is the questions. A solution of substance X is used for whitewashing. We saw that for whitewashing, we use calcium oxide. This calcium oxide combines with water to form calcium hydroxide. Okay. So this calcium hydroxide, is the one we use for whitewashing. So calcium oxide we will use, that will combine with water and it will form calcium hydroxide. Next one is, why is the amount of gas collected in one of the test tube? So in that activity we saw that electrolysis of water, right? We get 2 parts of hydrogen and 1 part of oxygen, because we know that the water contains 2 parts of hydrogen and 1 part of oxygen. So upon electrolysis also, we will get a hydrogen gas collected in one of the test tube is double, because we have H2 and O. Okay, that's what we get, 2 portions of hydrogen gas and only 1 portions of oxygen gas produced in a test tube. Okay. So please like my video, share and subscribe. Thank you, students.